Hello, class.
Hello, Mr. Verdi.
Welcome to another video lesson. Today we're on 11.4, area of irregular shapes. We've had a lot of different formulas in this unit. We've had a trapezoid, 1/2 height, base 1 plus base 2, a circle, pi r squared, triangle, 1/2 base times height, regular polygon, 1/2 perimeter times apothem. So when we have these odd shapes, how would you find the area of this arrow type thing? How would you find the area of this tent iceberg looking thing, whatever that thing is? Okay? Well, our strategy, there is no such formula for these irregular shapes. But our strategy is going to be to break shapes up into figures that we can find the area of. I could find the area of this square, base times height. I could find the area of this triangle, 1/2 base times height, and add them up together. I can take my sword and slice right there. And then I have 1/2 base times height for the triangle, 1/2 height base 1 plus base 2 for that trapezoid. So that's the strategy in every problem basically in this lesson, is we are going to break, you could write this down in your notes, break up figures into shapes that we can take the area of, that we can find the area of. So that's what we're going to do in this lesson. We're going to break our figures down into shapes that we've done before in the past, and then we're going to kind of add up all those shapes, all those areas. Here's the first one. Find the area of the orange region. The area of the orange region is basically the whole rectangle, and we are going to subtract the white rectangle. So we're going to subtract this. So let's find the area of the whole thing. The area of the whole rectangle is base 100 times height 50. So we multiply, when we take 100 times 50, we get 5,000. Now we're going to subtract the white triangle because we don't want that. We only want the orange area. So the white triangle, what is the base and what is the height? Notice how the whole length is 100. If this is 25 and this is 40, that makes 65. So this has to be 35 because 25 plus 35 plus 40 makes the full 100. If this is 20 and this is 10, that totals 30, and we got to get a height of 50. So that would mean this length has to be 20, right? 20 plus 20 plus 10 is 50. So now we can do the area of the white rectangle there is base 35 times height 20. So the area of that white rectangle is 700 centimeters squared. So what is the area of the orange region? Is the whole rectangle 5,000, subtracting the 700 for the white rectangle. 5,000 minus 700 is 4,300 centimeters squared. Square centimeters. Okay, next one. How do we find the area of this monster-looking thing that's going to eat your head off or something like that? I don't know. If I were to break this figure up into figures that I can find the area of, I would take my sword and I would slice this part off right there. And that's a trapezoid, right? So that's easy enough. So now this next part, what would we do for the next one? I have heard of students that want to slice right here, and then we would have two parallelograms. That's a good thought, and you could do it that way. But what I would propose to you is, what happens, class, if I slice the figure right there? Notice how this and this length are equal to this length and this length. So really what I could do is I could just put this part and fit it perfectly right in there. And isn't that nice and convenient? Now we would have a perfect rectangle. It's like this part, you cut it off and you just substitute it right into here. And now we have a perfect rectangle. So that's how we're going to solve this one. We have this rectangle, base times height, and we're going to add it to this trapezoid. Okay? So the area for base times height is a base of 35. I kind of made a mess of this here. Just going to take a moment here. So the base is this 35 times the height of 20. 35 times 20. If you take 35 times 20, you get 700 square inches. So now we got to add that to the area of this trapezoid. And the area of a trapezoid is 1/2 times the height, base 1 plus base 2. We know what one base is. It's 30. That's easy enough. The other base, notice from here to here, is 35. So 35, subtract 5 inches this way and 5 inches this way. The other base has to be 25. And then the height, this distance right here is my height. What does my height equal? Well, from top to bottom, we're given is 30 inches. Subtracting this 20, 30 minus 20 is 10. So my height is 10. All right, if you put that in your calculator, half of 10 times 55, 1/2 times 10 times 55 is 275. So the area of this whole monster-looking shape is 700 plus 275, which is 975 square inches. All right, looking on our next one, we have a grid. It says find the area of the pentagon. Oftentimes when people see this, they're like, Mr. Berge, we can do 1/2 perimeter times apothem. That's if the pentagon is regular. If it's a regular pentagon, you could use 1/2 perimeter times apothem. It doesn't say it's regular. Let's graph it and see if it is regular. So -5, 0 is right there. Left 3 up 7 is right there. Right 1 up 10. Right 3 up 7. Right 3 up and down 0. So class, is this regular? The answer is no. This looks like a bad constructed house, a leaning house or whatever like that. So we're certainly not going to use 1/2 perimeter times apothem. So what are we going to do? We're going to take out our sword again. And we're going to cut this figure up into figures that we can take the area of. I would say let's slice it right there. And now we have a triangle, 1/2 base times height. And then this part right here is going to be a trapezoid. And we can find the area of the trapezoid. So here is the area of the triangle. It is 1/2 base times height. The base is 1, 2, 3, 4, 5, 6. The base is 6 units. The height is 1, 2, 3 units. So 1/2 of 6 times 3, 1/2 of 18 is 9. There are 9 square units in the triangle. Now let's do the trapezoid. The area of the trapezoid is 1/2 times the height, base 1 plus base 2. What is the height of our trapezoid? 1, 2, 3, 4, 5, 6, 7. The height is 7. The sum of the two bases, one base is 1, 2, 3, 4, 5, 6, 7, 8. And the other base is this same base as the triangle, which was 6. So 1/2, 7 times 14, that comes out to be 49 square units. So the area of our pentagon is 9 plus 49, which is 58 square units. Never a bad idea to kind of conceptually see if that makes sense. Is there about 58 of these squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? We can count some partial pieces, and we would get about 58, or exactly 58. All right, here's another pentagon house-looking shape. Again, we're going to do the exact same thing we did with the last one, basically, is we're going to cut it right here. And that way we could find the area of the triangle and find the area of the rectangle. The rectangle, the area of the rectangle is base 9.2 times the height of 3.6. 9.2 times 3.6 is 33.12. And then the area of the triangle is 1/2 base times height. The base is easy enough to find. This is the base. So the base is 9.2. The height, however, is this distance. It's not quite given to us, but we can certainly find it, right? The height of the whole figure is 8, and then this right here is 3.6. So then this has to be 4.4. So the height of the triangle is 4.4. So 1/2 times height times the base, 9.2 times 4.4 times 1/2 is 20.24. So the whole area then of the pentagon, 33.12 plus 20.24 is 53.36, again in units squared. I always think of this next one as kind of looking like a basketball court kind of a thing, if we were to put on the 3-point line kind of thing, right? Basket right here. Whatever, there's the basket. Okay, if we were to find out how many square feet we would have to use to paint the lane of that basketball court, what I would do is I would break this up right here. And so then I would get a rectangle. And by the way, this 32, I should have made this more clear. It goes from here to here. So the area of the rectangle is base times height. And what would you call this shape right here? You'd call it a half circle, wouldn't you? So it would be pi r squared divided by 2, a semicircle or a half circle. So the area of the rectangle is 16 times 32. If you take 16 times 32, that's 512. And then if you take the half circle, pi r squared divided by 2, notice how the diameter is 16. This diameter is 16, so that means the radius is 8. So pi 8 squared divided by 2. 8 squared is 64. 64 divided by 2 is 32. So you have 512 units squared and 32 pi units squared. Square units. That would be the exact answer. I could approximate this if I wanted to, but right now we'll just leave it as the exact answer. Let's kind of maybe skip the next one and go on to the last one because it's kind of the same type of thing. This one I think of like a hockey arena. How many square feet of ice would I have to use to have a whole sheet of ice on this hockey arena? What I would do again is kind of the same thing. Let's find the area of this rectangle. It's a 10 by 4 rectangle, and 10 times 4 is 40 square units. And then what is a half circle plus a half circle? A whole circle, right? So then we could add the area of a circle, pi r squared. Again, just like the last one, the diameter is 4, so that means the radius is 2. So we have 40 square units for the middle rectangle, and then the 2 half circles is 4 pi. 40 plus 4 pi, we always should label square units. And the last one, we see something that looks like this. Some might say, Mr. Berge, we can draw a line right here, and now we have 2 triangles. And I would say, you're absolutely right, we can do that. Some might say, Mr. Berge, we can draw a line right here, and then we would get 2 triangles. And I would say, absolutely right, we can do that. Some might say, Mr. Berge, we can draw a triangle right here, and right here, and right here, and right here, and we could add up those 4 triangles, and we would get the area. And I'd say, yep, you can do that. And I would say, let's do this the easiest way. This sucker is a kite. So if it's a kite, the area equals 1/2 diagonal 1 times diagonal 2. 1/2 d1 times d2. So one of these diagonals, 1, 2, 3, 4, 5, 6. There we go. 1/2 times 6 times the other one, 1, 2, 3, 4, 5, 6, 7, 8. 6 times 8 is 48, and half of 48 is 24 square units. All right, that concludes our lesson on area. Be sure to let me know if you have any questions when you get to class tomorrow.